Now, in this video, we will see a typical Bernoulli differential equation where we have to reduce this to a linear first order differential equation in order to solve it. Okay, so we will see the procedure step by step. Now, the given equation, if you see dy by dx plus p of x into y is equal to q of x into y power n. Okay, this is one term which is something different from the regular first order linear differential equation that we have. What is it? Dy by dx plus p of x into y is equal to q of x. We know how to solve this equation, okay, by finding out the integrating factor and writing the general solution equation. We can find y of x. Okay, we have a straightforward procedure for this. But how do we solve this particular differential equation? Okay, here we need to reduce this to the linear first order differential equation. What is that we have to do? Okay, so here if n is equal to 1, okay, so what will be the differential equation? Dy by dx plus p of x into y is equal to q of x into y. Okay, so you take this to the right hand side. Dy by dx is equal to q of x minus p of x into y. Now this becomes a variable separable problem. Okay, so dy by y is equal to q of x minus p of x into dx. Okay, so you can integrate it on both sides. This is using variable separable technique and you can find the solution. But what if n is not equal to 1? How do you solve this? Let's see that in the next slide. If n is not equal to 1, then dy by dx plus p of x into y is equal to q of x into y power n. Now divide the entire equation by y power n. Divide the entire equation by y power n. Okay, so what is that we get here? This is nothing but y power minus n into dy by dx plus y power 1 minus n into p of x is equal to q of x. Okay, now let y power 1 minus n is equal to some z. Okay, now differentiate this. What will you get? 1 minus n times y power minus n into dy by dx is equal to dz by dx. So y power minus n into dy by dx is equal to 1 by 1 minus n into dz by dx. Now let's substitute this here in this particular equation. What is that we get? 1 by 1 minus n into dz by dx plus z times p of x is equal to q of x. This can be written as dz by dx plus z times 1 minus n into p of x is equal to 1 minus n times q of x. Okay, now this is a linear first order differential equation. Differential equation in Z. Okay, you can solve this. You can find the integrating factor, write the general solution in Z. General solution for Z of x. Okay, and then substitute Z is equal to y power 1 minus n to get the solution y of x. Okay, so this is the standard procedure that you follow in solving a Bernoulli equation. Alright, so now let's take one or two illustrations so as to make ourselves comfortable solving differential equations which are of Bernoulli type. Okay, now solve dy by dx plus y tan x is equal to y square secant x. What will you do here? So dy by dx plus y tan x is equal to y square secant x. Okay, now divide by y square. Divide by y square on both sides. Now this is nothing but y power minus 2 into dy by dx plus y power minus 1 into tan x. This is equal to secant x. Take y power minus 1 as z. So what will you get here? Minus 1 times y power minus 2 into dy by dx is equal to dz by dx. So y power minus 2 into dy by dx is equal to minus dz by dx. So when you substitute this in the equation here, you get d minus dz by dx plus z tan x is equal to secant x. Now multiply with minus dz by dx minus z tan x is equal to minus secant x. Okay, now p of x is equal to minus tan x. Okay, what is the integrating factor? E power integral p of x dx. This is equal to e power integral minus tan x dx. So this is e power minus ln secant x. Okay, so you can take this as e power ln cos x. So if you take the minus inside, it becomes 1 by secant, which is nothing but cos x. So this is nothing but cos x. Let's write the general solution. What is the general solution? Z times cos x is equal to integral times minus secant x cos x dx plus c. Okay, what is z equal to? 1 by y. So cos x by y is equal to minus x plus c. This implies y is equal to cos x by c minus x. This is the general solution. Okay, you understood? First we have taken this approximation according to the basic rule. Then we have the linear first order differential equation in Z. We solve that by calculating the integrating factor, then the general solution. We substituted back Z as 1 by y and we got the general solution in y. Okay, now let's take up another illustration. What is the differential equation? E power x into dy by dx is equal to 2x y square plus y e power x. Let's try to rearrange this. This is nothing but e power x into dy by dx minus y e power x is equal to 2xy square. Okay, let's divide by e power x on both sides. Dy by dx minus y is equal to e power minus x into 2xy square. Now let's divide by y square. Y power minus 2 into dy by dx minus y by y square, which is nothing but y power minus 1. This is equal to e power minus x into 2x. Okay. Now take y power minus 1 as some z. So this is minus 1 times y power minus 2 times dy by dx is equal to dz by dx. This implies if you take the minus to the other side, y power minus 2 times dy by dx is equal to minus dz by dx. Okay, now substitute this in this equation. What is that you get? Minus dz by dx minus z is equal to e power minus x into 2x. Okay, multiply with minus, what is that you get? Dz by dx plus z is equal to minus e power minus x times 2x. Now what is p of x here? Nothing but 1. That implies integrating factor is e power integral p of x dx. This is nothing but e power integral dx equal to e power x. Okay. So what is the general solution? Z into e power x is equal to integral minus e power x into 2x into e power x dx plus c. Okay, you can cancel these two. Z you can write it as 1 by y. E power x by y is equal to minus 2 times integral x dx plus some c. Okay, so this is nothing but e power x by y is equal to minus x square plus c. This is e power x by y plus x square is equal to constant. This is the general solution. Okay, this is how you need to solve equations which are of the type Bernoulli's equation by converting them to a linear first order differential equation and then substituting back the substitution that we have taken in order to convert them to linear first order differential equation. I hope you understood the basic concept. I will be back with another concept in my next video. Happy learning and thank you.